This video will be focusing on solubility and solubility curves. For this video, you'll need to know how to read a graph, and you'll also want to have a calculator with you so that you can follow along and do the calculations as we go through them. Let's look at solubility. So what is solubility? Solubility is how much of a solute dissolves in a given amount of solvent. There are two major factors that affect the solubility of substances. The first is temperature, and the second is pressure. But for pressure, that is only for the gases. It does not affect solids or liquids in any way. So first, we'll look at the effect of temperature on both solids and gases. To start with, for solids, we find that in general, solids are more soluble in hot than in cold solvent. Notice that it does say generally. Here we have a solubility chart which shows how temperature and solubility are related. This is only for the solids. So you'll notice that in general, as the temperature increases, the solubility increases. Once in a while we get a very rare exception, where the solubility decreases as the temperature increases. In the case of gases, we see quite a different thing. We see that gases are always less soluble in hot solvent than in cold solvent. Notice that this does say always. Rarely on a test do we say always, but in this case, you will see the answer is always. Let's look at what those look like. In their solubility curve, we see that they will, as the temperature increases, the solubility goes in the downward direction. The numbers are irrelevant for this, but we do notice that it is going downward in all of these cases. So again, this will vary for both the solids and the gases. The amount of solubility varies, but for solids it generally becomes more soluble. For gases it becomes less soluble as the temperature increases. The first four examples we see here are all solids, and so you can see that their solubilities are increasing. The last two are gases, and you can see that their solubilities are decreasing. Do you see any of these that do not follow the rules? Hopefully, you notice that lithium carbonate has become less soluble as the temperature goes from 20 degrees Celsius to 100 degrees Celsius. That is not common for a solid, but it does happen rarely. So again, on these charts, we notice that the solubility is given at a specific temperature, and it is the number of grams of solute for every 100 grams of solvent, in this case water. If we look at KNO3, we see that 37.8 grams of solute dissolves in 100 grams of water at 20 degrees Celsius. If I try to add more in, let's say I add a little more KNO3 and I add 40 grams, what we'll see is that 37.8 grams of the KNO3 will dissolve, and the leftovers will stay in the bottom of the container. But if the temperature is raised to 100 degrees Celsius, we see that now 247 grams of KNO3 will dissolve, and so that same 40 grams will be completely dissolved. Now let's look at what we can do with those numbers. So this is the format for a solubility curve. We're going to be looking specifically at KNO3. Remember that solubility is the number of grams of KNO3 that dissolves in 100 grams of solvent. In this case, our solvent is water. And then that is going to change dependent upon the temperature. We know that the solubility of KNO3 in water at 20 degrees Celsius is 37.8 grams. So what we're going to do is show that on the graph here. We'll go to the 20 degree mark, we'll rise up, and we're going to stop at the point of 37.8. And we see the solubility of KNO3 at 100 degrees Celsius is 247 grams of KNO3 per 100 grams of water. We look on our chart at 100 degrees, we rise up until we get to the 247, and now we're going to connect those dots, which gives us the solubility curve for KNO3 in water. So what can we do with the solubility curve? Well, one of the simplest things we can do is to find out what is the solubility of, in this case, KNO3 in water at various different temperatures. So here let's ask, what is the solubility at 50 degrees Celsius? For this type of problem, you go to the 50 line, 50 degrees Celsius, rise up, and read across. And you should see as you read across that it is just above the 100-gram line. I know my line wasn't very straight, but here I would say that it was just above the 100 grams. That's why I would say it was about 102 grams of KNO3 for every 100 grams of water or solvent. So how accurate do we have to be here? Well, I picked 102, but you may have ranged anywhere between 98 and 105 grams of KNO3 per 100 grams of water, and you would be just fine. And this range is allowable because we've hand-drawn the solubility curve, and we're hand measuring the temperature and solubility of the compound that we're measuring. Okay, so it's time for you to try it. What is the solubility at 70 degrees Celsius of KNO3 in water? Please pause the video while you try it and then restart it. So for that, we'll start at the 70 degree point, go up until you hit the line, and when you hit the line, you read across, and you'll see that that ends up around 160 grams of KNO3 per 100 grams of water. And what do you get for 90 degrees? At 90 degrees, you go up, you hit the line, and you go across, and I see that it's between 200 and 250, and in this case, it appears to be about 215 grams of KNO3 per 100 grams of water will be dissolved. So that's the basics of finding the solubility for 100 grams of water or solvent. What can you do if you don't have 100 grams, and what else can we do with the solubility curve? So let's see what else we can do. So here we have a solubility curve which plots the maximum amount of solute that can dissolve in 100 grams of solvent at various different temperatures. In this case, we're looking at KNO3 dissolving in water. Now that we have this curve, what can we do with it? One of the major things that we can do is, looking at any given solution, we can decide if that solution is saturated, unsaturated, or supersaturated. Recall that a saturated solution is any solution that contains the maximum amount of solute that can dissolve in the given amount of solvent at whatever temperature you're measuring. And of course, an unsaturated solution has less than the maximum that can dissolve at that given temperature, and supersaturated has more than the maximum amount of solute that can dissolve in whatever solvent you have at that temperature. And of course, the solubility curve shows us the maximum amount that can dissolve in 100 grams of water at various different temperatures, which means that any solution that is proportional to the solubility curve is going to be a saturated solution. So what happens if a solution does not touch the curve? What kind of solution is it? Well, that depends on whether it becomes above or below the line of saturation. If it's below the line of saturation, that means it has less than the maximum amount that can dissolve at that temperature, and it is unsaturated. On the other hand, if it has more than the maximum, which we see above the line, we will find that that solution is supersaturated. So we now know how to draw the solubility curve, decide what areas are saturated, unsaturated, and supersaturated, and find the concentration of various solutions. Let's put that all together to find out what kind of solution we have if we're given the amount of solute, the amount of solvent, and the temperature of the solution. The first step would be to draw this curve from any information that was given. So we'll have our curve that tells us the solubility of the substance at various temperatures. We're going to try this one, which has 150 grams of KNO3 in 100 grams of water, and we're going to look at that at 70 degrees and then at 30 degrees.
So let's find what that concentration is. The concentration is 150 grams of KNO3 in 100 grams of water. That's how much we have in our actual solution. It's not the solubility, just the actual concentration. Now we just need to compare what we actually have to what the solubility of the substance is. So at 70 degrees, we see that the 150 grams of KNO3 per 100 grams of water is below the solubility curve, which tells us that this is an unsaturated solution. And at 30 degrees, we see that it is above the solubility curve, which means that it is a supersaturated solution. So that's all you need to do if you happen to have 100 grams of solvent. Now let's look to see what happens if we don't have 100 grams of solvent. What if it's a different number? So in this case, we're going to have the same solubility curve with the blue line being our solubility, and it'll be our saturated solutions. Anything below the blue line will be our unsaturated solutions, and anything above that will be our supersaturated solutions. So exactly the same as we've done before. In this case, we're going to look at what type of solution do we have if we have 250 grams of KNO3 in 200 grams of water, and that's where our big difference is going to be. We're not using 100 grams this time, we're using 200 grams. You probably could guess what the answer is, but we're going to go ahead and show you how to do the math so that it can work out well. And then I'm going to have you try it for the 30 degrees Celsius one. So to start this problem, what you need to do is say, well, how much would I have if there were 100 grams of water instead of 200 grams of water? So we make a ratio. We say 100 grams of water, and then the ratio that we have is 250 grams of KNO3 for every 200 grams of water. And the answer to that is 125 grams of KNO3. Now remember, that's how much is going to be in the 100 grams of water that we started with. So that tells us that our solution contains 125 grams of KNO3 in 100 grams of water. We're going to go to the 70 degree line, go up to the point where we have 125, and of course in this case you'll see that it is unsaturated. Now you can try that for the 30 degrees Celsius one and see what you get. Again, the numbers will be the same, but I want you to get the idea of how to do the math. And again, we're going to have 125 grams of KNO3 in 100 grams of water. That is the same as 250 grams of KNO3 in 200 grams of water. We go to the 30 degree line, we go up to 125, and you will see, of course, that that is in the supersaturated region. So that is a supersaturated solution at 30 degrees Celsius. Next, you're going to try this, but we're going to use a little bit more difficult number. We're not going to use the 200 grams of water that we did in this one. It's going to be a little bit harder. So you might want to get your calculator out for the next one. So this is a you try it. We're going to use the same KNO3 solubility curve as we've done before. In this case, I want you to do just the first one, and that is what kind of solution would you have if you have 45 grams of KNO3 in 85 grams of water at 60 degrees Celsius. Pause the video and then start it again, and then we'll do number 2. So you probably noticed that we do not have 100 grams of water, so we need to change this to the 100 grams of water solution. See how much KNO3 would be there if there were 100 grams of water. So we start by multiplying 100 grams of water by the ratio that we currently have, which is 45 grams of KNO3 in 85 grams of water. And that gives us about 52.94 grams of KNO3 in 100 grams of water. Next, we need to draw that line in, placing it around 53 grams of KNO3 per 100 grams of water. We draw this line, and that shows us where the concentration of this solution is if we had 100 grams of water. So it is still the same ratio, but given that we have 100 grams of water so that we can compare it to the solubility curve. And now we go to the 60 degree temperature. We go up until we hit that concentration of about 53 grams of KNO3 per 100 grams of water. And we see that that is in the unsaturated region. And you can pause the video to try the next one. And for the second one, we have 925.5 grams of KNO3 in 1,234 grams of water. And again, we want to find out how much that would be if I had only 100 grams of the water. And so we're going to take 100 grams, multiply it by 925.5, divide that by 1,234 grams of water, and we'll find that we have 75 grams of KNO3 for every 100 grams of water. And then we draw a line going straight across at the 75 grams of KNO3 per 100 grams of water line to show that that is the concentration of our solution at all different temperatures. That's the amount that we have in the container. And then you go, as we did before, we go to the 40-degree line. You rise up until you hit that line of 75 degrees. And in this case, it appears to be right where the saturated point is. So that would be a saturated solution of KNO3. And next we're going to look to see what would you do if you were not given a graph. If you were just given some information, some numbers that told you what the solubility is, how would you know if you have a saturated, unsaturated, or supersaturated solution? And again, we're going to try this with some numbers that are not 100 grams of water. So you'll notice that in this case you are not given a graph. Instead of the graph, you're given the information about what the solubility is at that given temperature that we're going to be studying. So in this question, we want to know what kind of solution do we have if we have 496 grams of KNO3 in 368 grams of water at 40 degrees Celsius, if we know that the solubility of KNO3 at 40 degrees Celsius is 75 grams of KNO3 per 100 grams of water. Now obviously there's a lot of numbers there and it might be a little confusing to you. The main thing we need to know is that the temperatures that we're looking at are the same, so we're looking at 40 degrees Celsius for both of these solutions, and that the saturated solution is going to be if there's 75 grams of KNO3 per 100 grams of water. That's what the solubility tells us. If we have less than that ratio, then it's going to be unsaturated. If we have more than 75 grams of KNO3 for 100 grams of water, it's going to be a supersaturated solution. So we're going to do that ratio. We're going to find out what the ratio is if there were 100 grams of water, just like we did in the previous questions, and then we can see what type of solution we have. So we start this problem as we did before with 100 grams of water. We want to find out what that ratio would be if there were only 100 grams of water. We take our 100 grams of water, we multiply it by 496 grams of KNO3 that we have in our solution, and we divide that by the 368 grams of water in the solution. And that answer is about 134.7 grams of KNO3 if there were 100 grams of water. And now we're going to compare that to our given solubility of 75 grams of KNO3 per 100 grams of water. And we see that the number that we have in our solution is far greater than the 75 grams per 100. And so our solution must be a supersaturated solution. If I asked this same question but asked for it at 68 degrees Celsius, you couldn't do it without a graph. Or if I told you what the solubility of KNO3 is at 68 degrees Celsius. So if I told you that that solubility was 150 grams of KNO3 per 100 grams of water, and that's at 68 degrees Celsius, what kind of solution do you have if you have the 496 grams of KNO3 and 368 grams of water? So now we're going to be looking at that at 68 degrees Celsius. And now we see that the 134 grams of KNO3 per 100 grams of water in our solution is less than the given solubility of 150 grams of KNO3 per 100 grams of water. And that tells us that this would be an unsaturated solution at 68 degrees Celsius. And now we're going to have a you try it. So you're going to try this one. I'd like you to pause the video, see how you do, and then start it when you're done. So we're going to start with our known solubility at 20 degrees Celsius, and that is 37.8 grams of KNO3 per 100 grams of water. If we get that exact amount for our solution, then it is a saturated solution. If we have a number that is larger than 37.8 grams of KNO3 per 100 grams of water, then it's supersaturated. And if we have a number that's less than the 37.8, we will have an unsaturated solution. So now all we have to do is find out what we have in our solution. Since we know solubilities are always measured in 100 grams of water, we're going to start with that 100 grams of water. We're going to multiply it by the ratio that we see. In this case, our 873 grams of KNO3 divided by 659 grams of water. That's for the solution that we know we're working with. And here we see that that is 132.4 approximately grams of KNO3 per 100 grams of water. Here you can see that the 132.4 is definitely greater than 37.8 grams of KNO3 per 100 grams of water. and so we have a supersaturated solution. Now you may not have needed to get your calculator out to see that that is greater than the 37.8 that we had to start with. So you probably could tell that this is going to be more than 100 grams of KNO3 and not even have to put that in your calculator. You can do that on the exam. You don't have to show work, so it is fine if you want to show it that way. If you saw that the number was going to be very small, let's say it was like 1 gram of KNO3 per 100 grams of water, then clearly you would know that that would be an unsaturated solution. But when it's close, then I would just go ahead and put it in the calculator.
Okay, so now it's time for you to try one. Where do you start these types of problems? You start by figuring out what you already know. So we know that we have 245 grams of solute and 753 grams of solvent. We also know that the solubility at 40 degrees is 20.8 grams of sodium chloride for every 100 grams of water, and that solubility is the maximum that will dissolve at 40 degrees. We can look at the ratio of the solute to the solvent, and we can see that we currently have 245 grams of sodium chloride in 753 grams of the solvent water. Now we need to compare what we have to the maximum, the solubility. But the solubility is in 100 grams of water. So we make a comparison that allows us to look at what we have if we only had 100 grams of water. So how do we do that? Well, what we do is we assume that we have 100 grams of water, and we look at the ratio that we really have, the 245 grams of sodium chloride in 753 grams of water, and we use that ratio to see how many grams that would be if we only had 100 grams of water. The answer to this will tell us how many grams of sodium chloride will be present in 100 grams of water. Here you can see that the grams of water cancels out. You can put that in a calculator and you'll see that you get 32.536 grams of sodium chloride, but that is specifically in 100 grams of water. So now we can compare what we have to the maximum, what we call the solubility. And you can see that what we have is greater than the maximum. And since we have more than the maximum, our solution must be supersaturated.